Hi, I like to talk about a project of mine which I've been working with Jan Zemke on the connected sum formula in instant and not fair homology. Along the way, we give a unified proof of the connected sum formula that works in Hegart monopole and instant and not fair homology. Our work is based on Atnayer, Vilavik, and Zarev's interpretation of the minus version of not fair homology through Sucher-Floer homology. So what they show is that the HFK minus of YK is isomorphic to the direct limit of the following directed system, where each member of the family denotes the Sucher-Floer homology of the knot exterior with slope gamma n, where gamma n denotes two oppositely oriented curves on the boundary torus of the form lambda minus n times mu, where lambda is any preferred longitude and mu is the meridian of the knot. And the transition maps in this directed system is given by the negative bypass maps. In the instant and fluid setting, the minus version of instant and not homology, KHI minus, is defined mirroring the Hegart-Floer picture. So we know that the negative bypass map and the positive bypass map fit into this type of commutative diagrams. And so that means that if we take the direct limit of the horizontal system, then the positive bypass map induces an well-defined action on the direct limit, which we call the U action. So the minus version was defined by Chen-Kun Lee as a direct limit of this horizontal system. And the positive bypass map is inducing the U action. With all this in hand, we are ready to state our main theorem. So the main theorem we proved was that the minus version of connected sum KHI minus of K1 connected sum K2 is isomorphic to the mapping cone of this map. U1 tensor 1 plus 1 tensor U2. So here we are viewing KHI minus of K1 as a C adjoint U1 module, and we are viewing KHI minus of K2 as a C adjoint U2 module. And the mapping cone of this map is also known as a different model for the derived tensor product of KHI minus of K1 and KHI minus of K2 over C adjoint U. Here C is the complex numbers. And the way we prove this is by first asking how can we build the Sucher knot complement of the connected sum from the disjoint union of the knot complements. So on the left, we have the Sucher knot complement of K1. On the right, we have the Sucher knot complement of K2. And we build the Sucher knot complement of the connected sum by first attaching two one handles. And once we attach the one handles, we realize that all we need to do is we need to attach two contact two handles along the knot L1 and the knot L2. Now the rest of the proof is to identify this contact two handles maps as some surgery maps and apply the iterated mapping cone formula to this link L, this two component link L described before. So by the iterated mapping cone formula, we have that the Sucher-Floer complex of the connected sum is quasi-isomorphic to this complex on the right. And we try to understand what are all these groups and what are all these maps in this complex. Using the same argument, we can also generalize one of Kronheimer-Markovka's theorem about the oriented skein triangle. So in the head version of instant and knot homology, they proved that if K plus, K minus, and K0 form the oriented skein triad, then their corresponding knot fair homology group fit into this exact sequence. And we can generalize their statement to the in KHI minus. So what we can prove is that if K plus and K minus are two knots and K0 is a two component link, then these groups fit into an exact triangle. So here the third term denotes the derived tensor product of KHI minus of K0 with this ring C adjoint U1, U2 mod out by U1 minus U2 over the polynomial ring C adjoint U1, U2. And that's all I had to say. Thanks for your time.